Okay, so you've dropped this stack of research on my desk, and this one right on top caught my eye. The title is quite something: a systematic meta-analysis of the reliability and validity of subjective cognitive load questionnaires in experimental multimedia learning research. Let's dive into that one.
Yeah, it's a bit of a mouthful, isn't it? But basically, it's looking at how well we can actually measure
Yeah.
that mental effort, that cognitive load people feel when they're learning something new, especially like from videos or interactive stuff.
Right, cognitive load, that feeling when your brain is really working hard to process information. And this paper is trying to figure out which questionnaires researchers use are actually, trustworthy for measuring that.
Exactly. That's the mission here. Which tools really work? What can we rely on? And there are some, well, maybe surprising things in here for anyone trying to learn more effectively.
Good. Because, our listeners want the insights without wading through all the academic jargon, so we'll cut through that. First things first, though. What is cognitive load? Let's start there.
Okay, so it stems from cognitive load theory. Uh, John Sweller back in the 80s really kicked it off.
hmm
The main idea is our working memory, the part of our brain that's actively thinking and processing right now. It's limited.
Like a computer's RAM, maybe. Only so much space.
That's a decent analogy, yeah. You can only hold and manipulate a certain amount of information at one time before you get overwhelmed.
Okay.
And this working memory is constantly talking to our long-term memory, where all our stored knowledge lives. This knowledge is organized into what the theory calls schemas. Think of them like mental frameworks or concepts.
So learning is basically about building better schemas in long-term memory, so working memory doesn't have to work quite so hard next time.
Precisely, that's the goal. Efficient, well-structured schemas free up working memory. Now, the theory usually breaks down cognitive load into three types.
Right, I saw that. What are they? Maybe give me an example.
Sure. First, you've got intrinsic cognitive load, ICL. This is just how difficult the topic itself is. It depends on how many elements or ideas you have to juggle simultaneously. That's called element interactivity. And crucially, how much you already know about it.
Okay, so trying to learn quantum physics with zero physics background would be super high intrinsic load.
Exactly. Lots of interconnected complex ideas, no existing schemas to hook them onto. The only way to change that load is, well, simplify the physics or build up your background knowledge first.
Got it. What's number two?
That's extraneous cognitive load, ECL. This isn't about the topic itself, but how it's presented. Think terrible instructions, confusing website layouts, distracting animations, anything that makes your brain work harder than it needs to just to access the information.
Ah, like those IKEA instructions where the diagram doesn't quite match the pieces. You're burning mental energy just figuring out the instructions, not building the thing.
Perfect example. Or the split attention effect they mention. Having to look at a diagram on one page and read the explanation on another, your brain's constantly switching back and forth, integrating them. That's all extraneous load. It should be minimized.
So good design matters. Keeping related things together, presenting them clearly.
Right. Things like spatial contiguity, putting text near the relevant part of a diagram, or temporal contiguity, showing an animation and narrating it at the same time, not separately. Little things that cut down wasted effort.
Okay, intrinsic is the topic difficulty. Extraneous is the presentation difficulty. What's the third one?
The third is germane cognitive load, GCL. This is often called the good load. It's the effort your brain should be spending actively processing the information, making connections, building those schemas we talked about.
Ah, so like when you pause a video lecture to think about how the concepts connect, or you try to explain it to yourself?
Exactly. That's the deep processing, the actual learning work. Now, there is some debate, among researchers whether GCL is truly separate from ICL. Are they just two sides of the same coin when dealing with complex stuff?
Interesting.
But for this meta-analysis, they stick with the three-factor model because that's what most of these questionnaires are trying to measure: ICL, ECL, and GCL.
Okay, so three types. And the paper said they're additive, like they just pile up.
Well, that's the basic idea, yeah.
Mm-hmm.
Total load ICL plus ECL plus GCL. But it gets a bit more complicated when your working memory is really pushed to its limits. The interactions might not be strictly additive then.
Right, okay. So if we understand these types of load, why measure them with questionnaires? We can't exactly, stick a probe in someone's brain, can we?
And no, not easily. Cognitive load is an internal state. It's subjective. So often the most practical way to assess it is just to ask the learner, how much mental effort did that take? Questionnaires are the standard way to do that systematically.
Relying on self-reporting. Makes sense. Are there different kinds?
Yeah, the paper mentions the PADIS scale. It's super common. Just one question basically asking you to rate your mental effort, usually on a 9-point scale. Simple, quick.
But just one question, maybe not that detailed.
That's the limitation from a research angle, yeah.
Yeah.
You can't really check its internal consistency, like different parts of the measure hang together.
Mhm.
So that led to these multi-dimensional questionnaires.
Trying to measure ICL, ECL, and GCL separately with multiple questions for each.
Exactly. And this study focuses on 4 big ones. Eysenck et al. From 2009, Leppink et al. From 2013, and another from 2014, and Klepsch et al. From 2017. Those are the tools under the microscope here.
Okay, let's get into the findings then. First up, reliability. How consistent are these questionnaires? If I use one, will it give me roughly the same picture each time under similar conditions?
Right. That's reliability. And specifically, they looked at internal consistency. Do the questions intended to measure, say, intrinsic load actually seem to be measuring the same underlying thing? They use a statistic called Cronbach's alpha for this. Alpha goes from 0 to 1. Higher is better. Generally, above 0.7 is considered acceptable. Maybe 0.8 is good.
So what did they find overall for these 4 questionnaires?
Overall, pretty good news, actually.
Where?
For intrinsic load, ICL, and germane load, GCL, the internal consistency was generally satisfactory, often above 0.8 across the board.
Nice.
For extraneous load, ECL, it was a little lower, averaging around 0.77, but still generally seen as acceptable. So, broadly speaking, the questionnaires seem reasonably consistent internally.
Okay, that's reassuring. Were there differences between them, though?
Yes, definitely. The Leppink et al. 2013 version seemed particularly strong, really high consistency, especially for GCL, which hit like 0.909.
Wow, that's high.
Yeah, the Klepsch et al. 2017 one also performed well across all 3 types. Leppink's 2014 version was satisfactory too, though fewer studies had used it, so maybe less data overall.
And the Eysenck one from 2009.
That one was a bit different. They only really had enough data to look properly at the ECL part, which was okay, satisfactory. But the key thing with Eysenck is that it measures ICL and GCL with only 1 item each.
Back to the single item issue. So it's harder to be sure about the reliability of those specific parts.
Exactly. It's a measurement concern. 1 item gives you less confidence than multiple items measuring the same thing.
Okay. Did anything else affect reliability? Like, does it matter how many answer options you give people? 1 to 5, 1 to 10?
Funny you should ask. They did look at that moderator analyses. And yeah, it seems the number of scale points did matter.
Really? Is
Yeah.
there a magic number?
Well, it varied slightly. For ICL, a 10-point scale seemed best.
Hmm.
For ECL, odd numbers 5 or 9 points were better than even numbers. And for GCL, believe it or not, an 11-point scale came out on top for reliability.
Huh. That's specific. So researchers should maybe tailor the scale points.
Ideally, based on this.
Hmm.
But the authors also made a practical point. Maybe just using a standard 9-point scale for all 3 is a good compromise. Easier to implement consistently.
Makes sense. Did other things matter? Like, does it matter if it's kids in school versus adults or what subject they're learning?
Interestingly, no. Those factors, educational setting, the specific topic, how the info was presented, didn't seem to make a significant difference to the reliability scores.
Okay, so they're pretty robust tools in terms of consistency, with scale points being the main tweakable factor. But reliability is just one thing. What about validity? Do they actually measure what they say they're measuring?
Right, the million-dollar question. Validity is about accuracy. Does the score really reflect cognitive load? The paper looked at 2 main types. Construct validity, does it fit the theory? And criterion validity, does it predict things it should, like learning outcomes?
Let's take construct validity first, how the loads relate to each other. Did the results match the theory, ICL, ECL, GCL being distinct?
Okay, this is where one of the really big, kind of surprising findings came out. Across all 4 questionnaires, they found a consistent positive correlation between intrinsic load, ICL, and extraneous load, ECL.
Wait, positive. So when learners felt the material itself was harder, they also felt the presentation was worse. Shouldn't those be separate things according to the theory?
That's exactly the point. The theory treats them as distinct sources of load. This finding suggests that, in the learner's mind, they might not be so separate. Maybe when something feels inherently difficult, high ICL, any slight imperfection in presentation, ECL, becomes more noticeable or frustrating.
Or maybe it's just hard feels hard. Like if I'm struggling, I might just rate everything as difficult, the topic, the explanation, the whole experience.
That's definitely a possibility. Learners might conflate the 2. Or perhaps truly complex topics, high ICL, are just inherently harder to present super clearly, leading to higher ECL as well. It really makes you question how cleanly learners can differentiate these two in their subjective experience.
Yeah, that's fascinating. Okay, what about the other relationships, extraneous and germane load?
There, the results lined up better with theory, mostly. For 3 of the questionnaires, Lepping 13, Lepping 14, and Klepsch 17, they found a negative correlation between ECL and GCL.
So higher extraneous load, lower germane load. That makes sense, right? If you're fighting a bad presentation, you have less mental energy left for the deep thinking.
Precisely. Or you might just be less motivated to put in that germane effort if the experience is frustrating. Wasted effort on ECL seems to crowd out useful effort on GCL.
Okay. And intrinsic versus germane load, ICL and GCL.
That was
Yeah.
less clear-cut. The relationship varied across the questionnaires, sometimes positive, sometimes not significant. It kind of mirrors that ongoing theoretical debate about how distinct ICL and GCL really are.
And you mentioned the icing questionnaire behaved differently here too.
Yeah, interestingly, the iSync one showed positive correlations between all the load types. ICL, ECL, and GCL all tended to go up or down together. The researchers suggest this might be because all its questions use the phrase easy or difficult.
Ah, so maybe it's just tapping into a general feeling of difficulty rather than cleanly separating the three types.
That's the suspicion. The wording might inadvertently merge the concepts in the learner's response. Shows how important phrasing is.
Definitely. Okay, that's construct validity, how the loads relate internally. Now, criterion validity. How do these questionnaire scores relate to actual learning outcomes?
Right. Does a high score predict good or bad learning? Generally, the results were quite consistent here and aligned with theory. For all the questionnaires, higher reported intrinsic load, ICL, was linked to worse learning outcomes.
Makes sense. If it feels too hard, you learn less.
Yep. Same for extraneous load, ECL. Higher reported ECL was also consistently linked to worse learning outcomes across all questionnaires.
Again, logical. Bad presentation hinders learning.
Exactly. Now, germane load, GCL, the good load, is where it gets slightly more nuanced. For the Klepsch and the Lepping 2013 questionnaires, higher GCL was positively linked to better learning outcomes.
So reporting more effort on deep processing led to better learning with those tools. That's what we'd hope.
Yes. But for the Lepping 2014 questionnaire, the link wasn't significant. And for the iSync one, it was actually negative higher reported GCL linked to worse learning.
Whoa, negative. That really casts doubt on how well that icing GCL item is working, doesn't it?
It certainly raises questions. Along with its single-item nature and the construct validity issues we saw earlier, it seems the other questionnaires might be capturing that beneficial germane effort more accurately.
Okay. What about prior knowledge? How did that relate to the load scores?
As you might expect, people with more prior knowledge generally reported lower intrinsic load and lower extraneous load.
Right. If you know more, the topic feels easier, and you're probably better at navigating even slightly clunky presentations.
Exactly. The connection between prior knowledge and germane load, however, was less consistent across the studies.
You might think more knowledge allows for more deep processing, so higher GCL. Why might it be inconsistent?
Well, maybe experts engage in deep processing more efficiently. They might be doing more germane work, but it feels less effortful to them, so they don't report it as higher load. It's not entirely clear.
It's interesting nuance. Okay, we've gone through reliability, validity. Let's boil this down. What are the main takeaways for someone listening who just wants to learn better?
Okay, key things. 1, thinking about your own cognitive load, how hard your brain is working, is genuinely useful. It helps you understand why some learning feels easy and some feels hard.
Right, it gives you a framework.
2, these questionnaires, despite being subjective, are reasonably reliable tools, so the research using them is generally built on consistent measurements.
Good to know.
3, and this may be the big practical one from the validity findings, that surprising link between intrinsic and extraneous load. If something feels really difficult to learn, pause and ask yourself, is it just the complexity of the topic, or is the way it's being taught or presented making it harder than it needs to be?
So don't automatically blame yourself for the topic. Evaluate the resource. Is it clear? Is it well structured? Could a different explanation make it click?
Exactly. Be a critical consumer of your learning materials. 4, actively engaging, putting in that germane effort, generally does lead to better learning, according to the better questionnaires. So don't just passively absorb. Summarize, question, connect ideas.
Find ways to actively process the information. Makes sense.
And finally, while maybe less direct for the learner, the choice of questionnaire does seem to matter for research, especially regarding validity. And for you personally, remember both the topic's difficulty and its presentation impact your load and success. Seek out resources that hit that sweet spot. Challenging enough, but clear.
Be mindful of both the what and the how of learning. Great summary. So essentially, these questionnaires are useful, reliable tools, but the way learners perceive and report the different load types doesn't always map perfectly onto the neat boxes of the theory, especially that ICL-ECL overlap.
That sums it up nicely. There's still nuance there that researchers are exploring.
Which leads us to a final thought for our listeners. Given how intertwined the feeling of difficulty, intrinsic load, and the quality of presentation, extraneous load, seem to be in our experience, what strategies could you develop consciously to get better at telling them apart in your own learning? How can you more effectively diagnose why something feels hard, and then seek out resources or approaches that truly address the bottleneck?
A really practical challenge, something to mull over.
Indeed. If this deep dive sparked your interest, definitely look more into cognitive load theory. Maybe even check out this meta-analysis itself. It's a rich area. Thanks for joining us on this deep dive.